No. There. All right, so we're going to do a problem a little bit like number 4. Okay, so give myself some space here. So this is not number 4. This is like number 4. Let's say that let's say that Tom and Frank live 30 miles apart, right? And somehow they live exactly across from each other. Actually, it doesn't matter. They just live 30 miles apart. Everybody with me so far? Not much has happened. Let me see. Let me make it exactly. Okay, good. So let's say that Tom starts traveling towards Frank at what is it, Jeff? I don't know. Let's say 10 miles an hour. And Frank starts traveling towards Tom at 5 miles an hour. Is everybody with me?
Yes.
Can you guys tell me right now, whose house will they be closer to when they meet?
Frank's house.
Frank's.
Yeah, Frank's going slower, so he's going to get not as far away. Tom's going to get closer, so they're going to meet closer to Frank's house. Is that really important to know? No, not necessarily, but you can kind of see how this works. Now, somebody tell me, if so, they're on the phone. All right, they're on the phone. Hey, what's going on? All right, let's meet. Let's just start traveling toward each other for this. Why? Because we're in this stupid math problem. Oh, okay. So they both leave their houses at the same time, and then at some point they meet. Was either one of them traveling for a longer time?
Yeah, maybe one is faster than other.
Let's try this again. They're on the phone.
Okay.
Say let's meet. So they both leave their houses at the same time. Then they travel, and then they meet. Did either one of them travel for a longer time?
No, same time.
Same time, of course. You guys, I don't know. I got a bunch of black boxes staring at me, so I have no idea if you guys are understanding so far. So they both went for the same time. So what can and we don't know what that time is, do we? So how long do they travel? How much time, how many hours have they traveled by the time they meet? You don't know, but I want you to tell me. You don't know what the answer is, but I want you to tell me how much time they traveled. You could do this. What does algebra do when we don't know something?
We make an equation.
Well, we make a variable. So what do you want to call time traveled?
X.
X, sure. Why not? Okay. I love you guys so much. Yes. All right, now tell me this. They've both traveled for the same amount of time. We're going to call that time X. Right? How far has Tom gone? How fast is Tom going? Anybody? No.
5 miles per hour.
Tom.
Oh, Tom, 10 miles per hour.
10 miles an hour. And he's traveling for X hours. How far has he gone? If he's going 10 miles an hour and he travels for 3 hours, how far would he go?
30 miles.
So what do you do with speed and time to get distance?
There you
multiply. So how far has Tom gone if he's going 10 miles an hour for X hours? All right, listen, guys.
10x.
Yes. If you go 10 miles an hour for 2 hours, that's 10 times 2, 20 miles. If you go 10 mile an hour for 8 hours, that's 10 times 8, 80 miles. So all algebra does is it captures the idea of what to do if you just knew this number. If I just knew how many hours, I would take it and multiply it by 10, right? That's all algebra does. That's it. If I only knew what it was, I would multiply it by 10. Let's call it X. Why were we going to call it X? Just because. We don't freaking know. Oh, okay. Then what are you going to do? Multiply it by 10. Oh, yeah. All right. So this represents how far Tom went. Now, how far did Frank go? Same way. How fast is he going? 5 miles an hour. So how far did he go after X hours?
5x hours.
5x.
Or I mean 5x miles. My bad.
All right.
So,
All right. So Tom went 10x and Frank went 5x. What's true about these three things? What must they do?
they're together. They both will travel completely 30 miles.
There, right there. Tom's distance plus Frank's distance, of course, has to be 30 because they're 30 miles apart. Is this a hard equation to solve now? No. This is 15x equals 30 divided by 15 divided by 15. So they're going to meet in 2 hours. All right, let's check that. How far would Tom go in 2 hours?
20 miles.
How far would Frank go in 2 hours?
10.
So together they would have traveled 30 miles in 2 hours. So that's when they're going to meet. Now, if you've been paying attention, I just did number 4 for you.
Yeah.
I just did number 4 for you. It's the same thing, but it's a circle. I don't care. You can tear the circle apart and make it a line. All that matters is the distance they have to go, not what shape it makes. So these are the same problem. Does that help at all, Wafa?
Yes.
Yeah. Okay.
Yes.
All right. I know people tend to just tune out when we're talking about word problems. I know. I desperately want them to make sense. Not be easy necessarily, but make sense. What the goal is, why we do what we do. All right. Because it's insanely powerful. Oh my God, it's so powerful. The idea of setting up an equation to model a situation, we can do things we could never do without being able to do that. Anyway, I'll stop. I'm going to clear all this away. Here it goes. All right, bye stuff. All right. Any other questions? That was a good one because this is a bit of a freaky problem. This problem is nice. There's really no algebra up here. You can just attack the numbers. This problem requires algebra. So does this problem. This problem. And this one doesn't. All right, so I already kind of went through that with you, just so to help you figure out when to do what. Anything else, guys, from homework? Some of y'all promised me you'd have questions from 3-5, but at least I got one question. I'm excited.
Yeah, that was my question. So I don't know. I think I'm out. Sorry.
No, you're fine. I mean, it's fine to not have questions, but it's not good to have questions and not ask them.
How about that last question, like the very final question, like question 13 on number 5 or 3-5?
Oh, okay. Let's see. So this starts up here. Yeah, it starts up here, right? So $1.25 for premium, 95 cents for standard. And what does this one ask? How many pounds of the standard should be put in a barrel with 20 pounds to create a mix worth $1.10 a pound? All right. And why does it make sense that that will work? If I mix standard mix in with premium mix, is it going to make this price go up or down? If I put some standard mix into the premium mix, is it going to make this price go up or down? If I mix some of this in,
Less, it's gonna go down.
yeah, does that make sense? Does that make sense? If I put some
Yes.
cheaper shit in with some expensive shit, the mixture should cost less, right? Than the premium shit did. Okay. So that's why this problem makes sense, because $1.10 is in between those two prices. So if I mix them, I expect a cost that's in between. All right. Now, number 13, what do you need to give a variable to? Oh, you're fine. What do you need to assign a variable to in number 13? What is it? They tell you straight up what you don't know. What is it you don't know? Somebody
X.
else. Oh, go ahead.
110.
So the variable is never going to represent something that we know. That's not the job of a variable. What is it that we don't know in number 13? What's happening out there?
We don't know the worth of the mix, right?
We do, right there.
Oh.
All right. Somebody else. Somebody read me the first 7 words, 6 or 7 or whatever.
Oh, the amount of
The
pounds.
pounds of standard mix.
Yeah, so are you guys all right? I desperately need more of you with me. I'm gonna make my standard plea. If anybody can turn the camera on that doesn't have it on, that would be great. But if you can't do that, you're fine. I need some interaction, or else I'm gonna go more insane than I already am. All right. The very first part of this tells you what you're gonna let X be. I don't know how many pounds, so let's pretend like we do know. Let's call it X. X is the number of pounds of standard. All right. Now look, 20 pounds of premium. Right? Somebody help me out who's got the book right there. How much was the premium? How much was that worth? Was it $1.25?
Yes, it is.
Can somebody else tell me what the total cost of 20 pounds of premium would be? How would you figure that out?
20 times 1.25.
Okay.
25.
Yeah, $25, right? You guys with me? That would be 20 times $1.25, because that's 20 pounds times $1.25 per pound. The pounds would cancel. You end up with money. And all right, here's where things get interesting. I've got X pounds of the standard stuff, and that was 95 cents. Is that right?
Yes.
Yes.
Look at me. It's almost like I work with numbers, and sometimes I remember them. Can you do the exact same thing? Somebody else that hasn't spoken yet. Can you do the exact same? What did we do here? We did the number of pounds times the cost per pound to get money. Can somebody do that with this information? What would you get? Take the price per pound times the number of pounds. What would I write here?
X
Anybody?
times
So
0.95.
All right. I don't know what's happening out there.
1.10.
No, the $1.10 has nothing to do
X.
with the standard mix.
X times 95 cents.
Yeah,
Mhm.
so it'll be 0.95 X. Okay, so I desperately need, this is not impossible to understand. I have no idea where you are with your understanding of this. Most of you. Some of you, I know you're doing pretty well. And everybody else is like, I'm just going to shut up because those guys are going to get the answer. So why do I need to speak up? All right. Anyway, I'm going, I don't know if you noticed, I'm going a little insane. But all algebra does, again, how would I figure out how much something cost? I would take the number of pounds times the price per pound. Number of pounds times the price per pound. So just because I don't know how many pounds doesn't mean I would do something different to figure out the price. How do I figure out the price? The number of pounds times the price per pound. That's what I would always do. Does that make sense? I would just always do that. So I do price per pound, 95 cents per pound, times an unknown number of pounds. All right, now listen. This is important. The final mix weighs how much?
110.
No, not costs how much.
It weighs
how much?
It weighs depending on how much standard mix we put in with that 20 pounds, right?
We know exactly how many pounds of standard mix.
We
totally do. We totally do. You ready? This is where people are like, I don't know what the hell this guy's on. I know exactly that there are X pounds of standard mix. Do you guys think I'm insane? It's okay if you do. You're like, well, that means you don't know. I do know it's X.
Okay. I kind of get what you mean.
In the same way that this is just a stupid symbol. This is just a stupid symbol. So if I had 2 pounds of standard and 20 pounds of premium, how many total pounds is that?
22.
22, crazy. If I had 7 pounds of standard and 20 pounds of premium, how many pounds is that?
27.
27. Well, I have X pounds of standard and I have 20 pounds of premium. So how many pounds is that?
20 plus X.
Yes, cool. I would have also accepted X plus 20. So how do I get money over here? We know how to get money over here. I take pounds times price per pound. Yes.
Yes.
Pounds times price per pound.
Mm-hmm.
Pounds times price per pound. Money plus money equals money. I've done too much. So all you got to do now is solve this equation. That's all you got to do. And if you're scared about the decimals, I don't understand you. You got to calculate. Who gives a shit, right? So this should be the hard part, is setting up the equation. Solving it should be relatively easy. All right. So I'm not even going to.
Yeah, that helps. Thank you.
Yeah, I was going to say, I'm not even going to ask if that helps because I just did a big chunk of the work for you. Well, with you. Let's say with you. All right. Anything else from homework, everybody? Anything else? Oh, here, let me make this all about me. Here we go. All right, guys, let me show you something I put up in Canvas that I need you to, if it's at all possible, I need you to print it out for tomorrow. It would really be great if most of you guys could have this printed out for tomorrow. Let me show you where it is. So we're going to do this tomorrow. Well, let's see where I'm at. Here we go. Right here, lines and correlation. Scatter plot. We'll do stuff for this in class tomorrow. Isn't that crazy? All right. So I just need you to print this out. Don't do anything with it because you're not even sure what we're going to do with it yet. So don't do anything with it. Just have it printed out and ready. You guys understand? Yes, okay.
Yes.
So just print this out, have it ready for tomorrow. Okay. Oh, all right. I don't know why I did that. All right. Pop. Okay, all right. So what I'm gonna do, today we're gonna do section 310. And then tomorrow we're gonna kind of talk a little bit about 3.9. And I know that 3.9 is not, there's no assignment for 3.9. I understand that. It's just a little something I want to throw in for those people who are going to take statistics. It'll give you a little bit of a head start on some stuff, right? And it's a beautiful application of lines in real life. It's kind of nice. Okay. Let's see. Okay, so what we're going to do, we're going to do section 310. If there's no more questions. Let me turn off my black hole back there. Save this poor astronaut. There we go. Bam. All right. I've got some funky trigonometry up here right now. Look at that stuff. Isn't that awesome? Look at that. Don't worry, we're not going to talk about this. This is not today's lesson. Don't freak out. All right. Oh, weird. Is that better? A little bit? Yeah. Now, what 310 does is it's an immediate kind of application of lines in a way that we might not have thought of before. Somebody help me out. Somebody help me out. Let's do this. Let me get rid of this here. Oh, all right. All right. So if I gave you this and I ask you, we did this yesterday, but let's see who remembers. Can somebody give me an answer to this? Let's see who remembers how this works. Can somebody give me an answer to that?
If X is 3, then Y is 1.
Good. Somebody else give me another answer.
5, 3.
Good. Somebody else?
7 and 9. 9 and 7.
All right. 9 and 7. I'm with you. And one more. Somebody else. Your time to shine.
4 and 6.
Careful.
6 and
4.
4.
Oh, 6 and 4. Okay, 6 and 4. I like. Okay. Right. Whoop-de-doo. And of course, what did I say yesterday? How long would it take to list all the answers?
Forever.
An infinite
Right.
amount.
So
of
what's a
time.
better way to give the answers to this equation? What's a better way? Instead of trying to list all of them, because that's going to take forever, right?
Plotting a few and drawing a line.
Yes, plot a few, draw a line, because every point the line goes through is an answer. So a graph is the quickest way to answer the question, what are the answers to this equation? You guys kind of with me out there? So the fundamental thing that sucks about this is that there's an infinite number of answers. That kind of sucks, right? Now look at this guy. Let's see, Jeff, what do you want to do? I don't know, Jeff. It doesn't matter. Let's do this. Is this going to work nice? I don't know, Jeff. No, it's not. Make this 4. There we go. All right. Somebody give me an answer to this. I'll start. 1, if x is 1, then -1 plus 4 is 3. Give me another answer.
5, 7.
5, 7. No. If x is 5, what's -5 plus 4? You guys see? If x is 5, -5 plus 4 is -1. All right, let me stop. Let me make sure that everybody's cool with what's happening. So normally, when I want to create a point from an equation, which letter right now is considered the input?
X.
Y is the output. So if I just pick any number for x, I can throw it in and figure out what y is. That's how we're creating these points, correct? All right, give me another one. Someone else.
So if x is -2, it would be a +6.
Yes, kick ass. -2 is 2, plus 4 is 6. That's awesome. I love it. All right,
Is
let me
that
make one up.
because
Ready?
of the understood 1 in front of the x?
Yes, sure. There's always an understood 1 in front of everything. What about 3.92 and 0.08? Just to make a point, right? If you don't believe me, put it in your calculator. Just to make a point. I mean, would any of us actually make that point? No, except for Jeff. He's weird. But that's just to remind you guys that there's an infinite number of points between any 2 points. There's an infinite number of points. Holy shit. Okay. It's like there's an infinite number of infinite points, infinitely going on. Okay, all right. Now watch this. So this is one piece of information. This is another piece of information. So if I say that both of these are true at the same time, I need both of them to be true at the same time. Right. I really want you guys with me here. Here, let me give you a concrete situation. If I said that, can somebody, all right, this is going to sound weird. I have no idea. Can somebody private message me your age? If you feel comfortable telling me your age, private message me your age. So you're going to know, private message me your age. Okay, I got it. So I got somebody's playing with me. I like it. Somebody's playing along with me. All right. So there's a student. When I take my age and add it to the student's age, okay, somebody's got a birthday coming up. So if I take my age, Jeff, plus this student, I get, all right, wait a minute, I gotta do it in my head. Yeah, I get 73 years. You guys with me? From that one statement, can you figure out how old we each are? There is one person that can, the person that I'm using their age, but you keep quiet. But tell you, Jeff's age plus the student's age is 73. Do you know how old each of us are?
No, we just know what you are.
Yes. No.
No, we don't know.
Oh,
We
couldn't
need
you
one
make-
of them.
Couldn't you make a bunch? I have no idea how old either one is. I mean, I do, but I mean, you don't know how old either one is, correct?
Yes.
Yeah.
Because why does it make sense? I don't know. There's 2 things I don't know, but I just gave you one piece of information. Oh, it's never going to work. So the number of things I don't know, that's how much distinct information I need to figure those things out. I think of it like a homicide. If you're a detective working a homicide, what do you go out to try to find? What are you looking for? There's a homicide. Somebody's dead. You walk in the room, you're like, somebody's dead. What do you start looking for?
Clues.
Clues. There we go. Got a large clue. Okay. What's that? Can't remember. Got a raging clue. I can't remember that. Anyway, you look for clues. Why? Because you have a lot of unknowns. Is that true? When you have a homicide, you see somebody's dead, there's a lot of unknowns. Do you agree with me? There's a lot of stuff you don't know, which means if you have a lot of stuff you don't know, you need the equivalent amount of things you do know to figure out the unknowns. Okay, all right. I don't know if you guys are with me at all. This is why we look for more and more evidence, because I have so many things I don't know. So I need a lot of information to figure those out. Now in algebra, it's a little more cut and dry. I have two things I don't know. I need two pieces of information to figure them out. Now, real quick, now watch. Couldn't this be, I'm 40 and the student is 33? Couldn't that be an answer?
Yes, can be.
Yes. Could it be that I'm, all right. I'm sorry. I was just going to say, if I'm 18 and the student is, what would that be? I can't even think now. That's so silly. 55. Now, obviously, mathematically, could that be an answer?
Yeah.
Realistically, could that be an answer? No.
Sure.
Probably not. You don't have a lot of 18-year-olds with white in their beards, right? So, but mathematically, it could. What about 48 and 25? Could that be the answer?
Yes.
Yes.
Yes. What if I tell you, what if I give you a second piece of information? What if I tell you Jeff's age minus the student's age is 23? Can we now eliminate some possibility? Could it be this one?
No.
No, because Jeff minus student is 7. No. Could it be this one?
No.
No. Could it be this one?
No.
No.
Yes.
48 minus 25. I love you guys so much. What is 48 minus 25?
23.
23.
So let me try. Let me ask this again. Is it going to be this one?
Yes.
Yeah, it can be.
Yes. Is there any other point that it could be? No. Are you guys almost with me? So this by itself gives me an infinite number of possibilities. If I give you one more piece of information, it can eliminate everything except one. There's only one thing that makes both of these true, and that's 48 and 25. Right, so now you know I'm 25 and I'm 48 and the student's 25. Okay. I like it. I don't mind getting old because that just means I made it this far. So keep going. All right. So coming back to this problem. I'm going to erase this. That doesn't help us because if I had to do that same thing every time, make a bunch of points until I find one that works in both, that would be horrific. That might take forever. So what we do instead is we graph the lines, because if I graph the line, that's equivalent to finding all the answers, correct?
Yes.
Okay, let me see now. Let's see if you guys can handle this. So for this line here, what is the slope? Can you guys see the slope? You can do it. Can you see the slope? What's the slope? Which letter is the slope?
M.
M. And what is where M is?
1.
1. Okay, that's all it is. See, that's it. That's the slope. 1. Let's make it 1 over 1. Is that cool to me? Rise over run. So if you ever get a whole number slope, go ahead and put it over 1, because then you have rise and you have run. All right, what's the y-intercept? What does B mean?
Y-intercept.
Sort of. It means the y piece of the y-intercept. So somebody else tell me, what is the y-intercept? Don't say -2 because that's wrong.
2,
Careful.
-2.
No,
No?
no. What's always got to be true at the y-intercept? X has to be.
What?
-1.
I love you guys so much. All right. If I hit the y-axis, what is the same about all those points? What do they all have in common? They have different
Y is 0?
X is 0.
Oh, X is 0.
Y is all these different things, but X is 0 for every single one of them. Doesn't that make sense? If X is 1, is that point going to be on the y-axis? No. If X is -1, is that point going to be on the y-axis? No. So this y-intercept is 0, -2. And let's check it. When I put a 0 in for X, what do I get? 0 I get -2. Are you guys with me out there? We've talked about all this, and this is where it's all coming together. And sometimes it comes together like this. But you got to wait until it goes, oh, I see. All right. Can you plot the y-intercept if you have created a graph like you should have as you take notes? Plot the y-intercept. Where is it? Let me give us some scale here. I'm just going by ones. Tell me how to get to the y-intercept. Starting it here.
And you go down 2.
That's right. And I don't go left and right at all. There we go. Now, from that point, what does the slope tell me to do?
Go over
One
1
over
and
one.
up 1.
Okay, over 1, up 1. I like it. Over 1, up 1. I'm going to do it over 1 for a little while. Over 1, up 1. I'm going to just do it for a while. Well, let me stop for a minute. You guys. Okay, thank you. So let's see if Jeff can draw a straight line. This is a tense moment for Jeff. Okay, that's not that. Okay, just make these points big. All right, now this line is, stay with me. I know this is not exciting. I understand. This line is all the answers to this. If I plot this line on the same graph, I can actually see the answer. The answer is going to jump out at me. So what do we know about this line? What's his slope? You can do it. What's in the right place to be the slope? What letter is slope?
M.
And what is in the position of m in our equation?
1/2, I think, is the slope.
Where do you see 1/2 in the equation? So isn't this the slope? Isn't the number in front of x the slope? What number is in front of x?
-1.
-1. And I'll put it over 1 for rise over run. Is that, you guys with me?
Yes.
Love it. All right. Some of you guys are like, you lost me at welcome to math 96. I'm like, damn. All right. What's the y-intercept for this guy?
0 minus 1. No, 0. 4.
4. So now I can plot the y-intercept, 0, 4. And the slope tells me to go how? How am I going to move from here?
1 down.
1 down.
1 down, sure.
All right.
And
1 positive.
1 over, right? Isn't it -1 over 1? Fall 1, run 1. Fall 1, run 1. Fall 1, run 1. Fall 1, run 1. So there's all the answers to that equation. So can you visually see What's the answer that works in both at the same time? Which point works in both?
1, 3.
Try again.
No, 3, 1.
3, 1. 3, 1. It's always x, y. Let's see. Does 3, 1 work in here? If x is 3, what's negative 3 plus 4?
1.
1. And then over here, we already know that 3, 1 works. That's the first point we got, right? Yeah, Jeff. Okay. So how do I solve? Oh, by the way, when I have more than one equation, we call that a system of equations. System of a down. No, system of equations. These are systems of equations. That's just the name we call them when I have more than one equation. In this case, I have 2. It's a system of equations. So how do I solve a system of equations? I graph both, and then I see where the graphs meet. That's it. That's all we have to do. You guys okay out there? You're hating life?
Oh,
Why
good.
do I suck so bad? Is that the question? Okay. All right. So that's it. Hopefully it makes sense, because that's sort of like what we were trying to do here. We were listing all these possible answers, but you'd have to be really lucky to just suddenly find the one that works in both. So the quicker way is graph one, graph the other, and just see where they meet. That's the answer. That's the answer to the system. Okay. All right. Let me erase all this. Notice that I did the slope several times. That makes it really clear where I meet. If you just sort of draw a line, draw another line, you might be like, where does that meet? I can't tell because, all right, I don't know if you guys are with me on that or not. So here, you guys solve this system of equations. Yeah. Mm-hmm. 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 Yeah, sure. Why not? Solve the system of equations. So let me kind of catch up to you a little bit. What's the slope of the first dude?
Two.
2, 1.
All right, 2 over 1. I like it. And what's his y-intercept?
0 minus 5.
0, -5. Kick ass. So then we can graph him. Let's see. So here's 0, -5. And then where am I going to go from there?
Up to. Move 1.
Over 1. I like it. Up 2, over 1. Up 2, over 1. Up 2, over 1. Up 2, over 1. All right, so there's him. Oh, shit. The scale's a little sucky. Oh. Now, on top of that line, I'm going to graph this dude. What is his slope?
-1, 1.
And his y-intercept?
0, +7.
So up here for 7. And then where am I going to go from there?
Down 1, over 1.
Down 1, over 1. Down 1, over 1. Down 1, over 1. Down 1, over 1. It's big, and then maybe it can be a line. Ah, shit. That's why you do the multiple steps, because if you're as bad as I am, I cannot draw a straight line worth save my life. And I still didn't do the greatest job here, did I? But oh well. Can somebody tell what that point is?
4, 3.
4, 3. I like it. And how do I check that answer? This is why you should get graph paper, everybody. How do I check that answer? I just plug it in. What's 2 times 4?
8.
8,
Minus 5 is?
3,
And what's -4 plus 7?
3.
3.
It works. So you can check your answers. So that's how you solve a system of equations graphically, is you graph each line, step back, see where they meet. And trust me, you're going to want to do the slope more than once, so you can really tell where they meet. Now, what if the answer to a system of equations, stay with me, will graphing always work if I'm graphing by hand? No. What if the answer was 1.187, comma, -4.2976? What if that was the answer? Are you ever going to get that answer by graphing by hand?
No.
Shit, no. I could barely get 4, 3 with my shitty ass graph. You want me to get that precise? Ain't no way. Could that be an answer to a system of equations? Hell yeah. All day long, that could be an answer. That could totally be an answer. Oh, shit. So graphical method is nice, but it isn't always easy. Sometimes it's nearly impossible. Is everybody with me? So you're all like, some of you guys are like, thanks for showing me a crappy method that doesn't work all. Well, come on, give me a break. So what we want to do is we want to develop an algebraic method, not a graphical method. There must be a way to do this without graphing. And anybody who doesn't like graphing is like, oh, good. Yeah, show me this shit. All right. So I'm going to erase this. I'm going to erase this. Here we go. if I had to solve this system, blah, blah, blah. Let's say one is x plus 4y equals 11. How about making one that works, Jeff? I think that would be a good idea. All right. And what if I was also told, yeah, sure, whatever. What is it? Okay. Okay. I'm trying to. So I created the equation to have a nice answer. I created the system of equations to have a nice answer. That's why I'm trying to make sure it works out. Help me out. This first equation sucks. And so does the second equation. They both suck because the number of unknowns is too damn high, right? That's why they suck, right? This equation over here why is that equation so wonderful compared to either one of these? Why is that equation so wonderful compared to either one of these? Why is that equation so awesome?
We just have X, no Y.
You only have x. I can subtract 3 and I can be done with the damn thing. I'm done. I don't need no lines. I don't need no other shit. I just get the answer. Yay. All right. So now watch this. This is such a cool method. I call this, it's kind of like Invasion of the Body Snatchers. All right. So I'm sorry if you don't like horror movies or whatever. You don't even have to look at it like that. Do you know what y is? In this equation, do you know what y is? Do you know what y is?
Not yet.
No.
Not yet. Good. Perfect. No, we don't have a clue, Professor. What this shit? Do you know what x is?
Not yet.
I disagree.
Yes, we have one.
Oh, I set you up for that. You ready? I know that x is y minus 4, don't I? Isn't that what this says? Doesn't this one say x is y minus 4? Doesn't it say that? Now, admittedly, I know some of you guys are like, that means I don't know what it is, Jeff. Do you understand? So I stick by my answer. But then I'm like, no. I know something. I know that x can be replaced with y minus 4 because of the same thing. I want this to really make sense. Do you guys agree that according to this system, x is the same thing as y minus 4?
Yes.
Yes.
So how can I rewrite this first equation in a better form? I see x. What can I put here instead?
Y minus 4
Yes.
plus y.
Huh? Yes, and then I keep going. So this, I replace it with what it is, plus 4y equals 11. Now, why is that equation better than either one of those? Why? Why is that equation better?
Because we have right now we have just y.
Just one variable. Yeah. Can
Yeah.
you solve that? Go ahead and solve it. Go ahead. I'll wait. Don't say anything. Just solve it. Solve that equation. I know my y's look like 4, so I'm sorry. Let me try to make them more pronounced. Is that better? Maybe. I don't know. So let's see. I mean, this should be easy, right? Y plus 4y is 5y. Is that cool? If I add 4, I'll get equals 15. And then, of course, I just have to do what?
Divide.
Divide.
Y is 3. Do I just circle that and go to the next problem? Am I done?
No, you have to plug it in.
Yeah. The answer to a system of equations will be a number for every variable you had. I have 2 variables. I need 2 answers. I need to know what y is, and I need to know what x is. Well, if I know what y is, can you figure out what x is?
-1.
Yeah, because x is y minus 4. So x is y minus 4. X is -1. So now somebody tell me, if I were to graph these two, what point would they meet at? We just figured out the point that these would meet at. Where would they meet?
-1,
-1,
-3.
3. There, sweet. So you can leave your answer like this. I love it. Or you can go one step further and write the answer as a point. The answer to a system of equations will always be the point or points where they meet. Oh, okay, understood. All right, somebody's having some technological issues. All right. So what did I do? I plugged in information about a variable so that I had an equation with just one variable. I used one piece of information along with the other piece of information. Isn't that what we do in real life? All right. So I want you guys to do this one. What time we got? Okay. I'm going to erase all this. Here it goes. All right, so solve this system here. Let's see. I don't know, Jeff. Sure. All right, wait a minute. Wait a minute. Oh, okay, that works. Yeah, I like it. Neato. It's like the Matrix won't let Morpheus back in. Let's see.
Can you hear me?
Yes.
Okay, I think my Zoom's gonna crash again.
Uh-oh, sorry, buddy.
I don't know what's happening. I'm so sorry.
It's the agents are attacking you.
Yeah,
McCorpheus. I'm going to call you McCorpheus.
for me.
All right. So I just to make sure, I'm going to take number 1 and I'm going to rewrite it somehow. Right? That's the idea. Using the other information I know. So what do I know? Which variable do I know something about? I don't want to say this.
Y.
Y.
know y. Y is this. That is what y is. So I'm going to rewrite the first equation in a better way. I'm going to replace y with what it is. So how would I rewrite the first equation using this information?
5x
5x
minus
plus,
1.
sorry, minus 1 minus x
So I just, in place of y, we put minus 1 minus x
equals 7.
equals 7, 11. So everything else, 5x plus y equals 7. So the whole equation has to still be here. I'm just substituting this. In fact, I don't think I've said this yet, but this is called the substitution method, which makes sense because I'm just substituting an expression for a letter. And now this is easy to solve, right? Please let this be the easy step.
4x
Good. 5x minus x is 4x. What am I doing over there? I'm thinking ahead.
8
8. There we go. And then
Divided by 4.
4. X is 2. So then what's y?
Y equal -1 minus 2
So
minus
I
3
know y is this, and I know x is 2 now.
minus 3.
-3.
Good. So then as a point, that would be
2
2
minus 3.
minus 3.
all right. So at least I know a couple of you fully get this. So I don't know, has anybody ever done this before? You guys remember anybody ever done substitution method before? Does this feel familiar to anybody?
Yes, yes. Yeah, this is
Couple of you guys. All right.
definitely.
This is kind of nice. I kind of like this. I like the other method better. It's called elimination. Just because I get to kill stuff, right? This is a little subversive. This is like you take somebody, you replace them with something, right? That's why I call it invasion of the body snatchers. Let me see what time it is. Oh, not too bad. Let me think. I gotta remember. I don't even know if the book does the other method. I can't remember now. Shoot. Here I am teasing this other method. And I cannot remember. Do they do the other method? It looks like they don't. Those dorks. What a bunch of dorks. All right, let me see. It doesn't look like they do. Oh well. Oh well, there's substitution. They don't talk about it, man. Oh well. Oh well. That's my favorite one. Yeah, the other one is where you just kill letters. You just go, I don't like you, I'm gonna kill you. All right. That's not a life lesson. It's fine to do it to math. Numbers and letters, they don't feel anything that I know of. That would be horrible. At the end of my life, I'm like, every letter you just canceled felt it. I'm like, oh no. All right, I think that's enough. I'm starting to get all goofy. I think that's enough for today. What do you guys think? I think that's plenty. So tomorrow, come ready with the printout of that worksheet that's up on Canvas. Right, the one about correlation, whatever the hell correlation is. All right, we're going to do that tomorrow, and then we'll get into chapter 4 a little bit tomorrow. Okay, that's enough for today. Let me know if you have any questions and you need to hang out afterwards.
Thank you, sir.
Sure.
I just got my camera to work, so that was
Sorry, buddy. Perfect time.
no big deal. All right, I have a good one, Professor. I'll see you
You.
tomorrow. Oh wait, actually, what? So I think I missed. There's a worksheet to print out worksheet for
Yeah, it's
tomorrow.
up on Canvas. It's called correlation. Let me show you.
Is it in module 3?
Yes.
Okay.
Lines and correlation. So it's the last thing in module 3.
Okay.
There we go.
Awesome. All right. Thank you, Professor.
You're welcome.
I'll see you tomorrow.
Okay. Everybody else okay?
If we don't have any access to a printer, can we just buy graph paper and like line it?
Yeah, you could copy it down. That's fine. Copy it down on another sheet of paper. Yeah.
Okay, awesome. Cool, man. Thank you.
Okay. See you tomorrow. Go, Kevin. You okay? Hello? I'm going to head out. Bye.